Okay, and hopefully you can see that. Share my screen there.
Perfect. Yep.
Great. Okay. Thanks ever so much. Hello, everybody. My name is Matt Hamilton. I'm a developer advocate on the FVM team at Protocol Labs. I did a talk a little bit about the intro to FVM and Filecoin earlier on, and you've also heard from a number of my colleagues so far as well as a number of people from around the Protocol Labs network. So that's great. So today I'm going to be talking about, this is going to be a bit more of a kind of a slightly more hands-on thing here. I don't have many slides. We're going to go through some code, going to go through an example of something you could build on Filecoin that kind of shows some of the uniquenesses about Filecoin and FVM. So there's been a number of talks previously from my colleagues such as Longfei, Zhangyan, and Zach, and I would definitely recommend checking those talks out because they cover a lot of some of the architecture that you might then be able to build on from this talk. So those talks will probably give a bit more of a background about some of the stuff here, but I'm going to try and cover some of the stuff from the beginning. But these other talks that they've done go into some more detail on some specifics around FVM. So I would definitely check them out, especially the Data DAOs and the RAS Workshop as well, because you'd be able to build, using knowledge from them, you'd be able to build a lot upon what I'm going to demonstrate here. So what I'm actually talking about here, I've created a thing called a replication certificate. So what is a replication certificate? It is an ERC 721 NFT that can verify the health of some data on Filecoin. So FVM, the Filecoin Virtual Machine, gives you a Ethereum compatible runtime that you can deploy Solidity smart contracts to, or anything that compiles down to EVM bytecode. So many people from the Ethereum ecosystem will be familiar with ERC 721 as a standard for NFTs. So it's a smart contract that represents a non-fungible token, right? Or rather a collection generally of non-fungible tokens within a series. Now, I thought, okay, well, that's great. You can do ERC 721 NFTs on any EVM blockchain. But what is unique about Filecoin? What can we do to demonstrate some of the unique features on Filecoin? And for that, what I wanted to do was demonstrate the fact that one of the things you can do with FEVM is you can actually look at some of the deal information that has resulted in data being stored on the Filecoin network. So just to recap, when data is to be stored on the Filecoin network, you have a client and you have a storage provider. The client and the storage provider negotiate the terms of the data storage. So how long, how much they're going to pay for, who's going to be storing it. And then once that's negotiated, that deal is published on the blockchain, right? And that's the bit that keeps everything honest and that verifies the data. So the data itself, terabytes, gigabytes, petabytes, whatever of data, is stored off-chain, but the deal and the proof of that data storage is stored on-chain. So every 24 hours, a storage provider has to respond to a zero-knowledge proof from the blockchain that proves that they still have the data there, right? So that proof and that deal information is what is on the blockchain. And that is what we can access via the filecoin.sol library that gives you access to some of the functions and functionality within the Filecoin network. So my idea here is to create an NFT that can actually interrogate what's called the market actor on Filecoin and look at the deal information to check that a deal is valid, right? So you might have a piece of data and you might have negotiated multiple storage deals with multiple providers, right, in order to get resilience and redundancy. So what we then want to do is we want to then have something that give you like a little certificate that proves that that data has actually been stored, has been replicated, right? Now, you could imagine this might be useful for some kind of regulatory reason. For example, you might want to have some kind of certificate that is, a stamp that says, yes, this data has been stored, has been replicated, and whatever. So we're going to create an NFT that dynamically looks that information up. So actually, what I'll do is I'll go through to actually end of the slides and then come back again just to kind of give you a bit of an example here. There's a dataset explorer. If you go to datasets.filecoin.io, and there's a whole series of data sets here. And you can see, so here we've zoomed in on some Landsat data. So this is satellite data, 32 gigabyte pieces of data here. And you can see there's multiple deal IDs for each piece with multiple storage providers in multiple different locations, right? So you can see there's a number of different storage providers, and that is what is providing the resilience on the network. Right, so what are we going to create here? What are we going to build upon? Two repositories here, FVM LocalNet. So FVM LocalNet is a repository of some Docker images that I created that can spin up a local network running local on your laptop. I mentioned earlier that things might be a little laggy in this video. That's because my MacBook Pro here is actually running a complete Filecoin network running locally here. So you can actually see this running away on my laptop. And to start this up, you can go to that repository and this Filecoin FVM LocalNet repository, and it gives you the instructions to fire it up. So it doesn't need to compile anything. You'll need to download a fairly large chunk of data, about 3 gigabytes of data for the small, what's called 2K network, or 7 gigabytes for the 8 meg network. Now, this has a number of benefits running this locally. On the Filecoin network in production, sector sizes are 32 gigabytes or 64 gigabytes in size. So it takes quite a lot of processing power to process those sectors. When some storage is sent to the network, it has to be sealed in a sector, and that process will take, a pretty beefy data center server with GPUs, a good, 4 hours or so to actually seal that data, require a large amount of memory, disk space, et cetera, et cetera. So this allows you to run locally on your network a much, much, much smaller network. So either a 2 kilobyte network or an 8 megabyte network. So the 2 kilobyte network means the maximum you can store per sector and per deal is 2 kilobytes of data. So it's really very small, but it allows you to run EVM smart contracts locally and test them. And the other good thing about it is it's a faster block time. So the main network is a 30-second block time. This is a 15-second block time. So it's just a little bit quicker when you're trying to demo stuff and when you're trying to test stuff. So basically, you can clone this repository. If you need to have Docker installed, you can clone this repository, go into it and just type Docker compose up, and it will spin it all up. If you want, there's also a profile I've called replication here, and that will run 2 miners and 2 boost instances. So if we actually go back and look here, you can see we've got Lotus Miner, we've got Lotus Miner 2 running here, and I've got 2 instances of Boost. Boost is the software that is used by miners to kind of manage the process going on the network. And we can actually see, I can actually bring this up here. Localhost 8080, I've got 1 here, and localhost 8081. These are 2 boost instances running. I started them up yesterday, so they've been running about a day ago, and there's 2 storage deals on each one. Now, for various reasons, one of the storage deals has failed. That's actually because I submitted it to both of them. Both picked it up, and they both tried to deal with it. So one processed it, one then failed. So I had to run it again a second time. So what you'll see is 2 deals, one which failed, and one is in the state proving, right? So when we go here, you can see proving. And so what that means is that the miners are actually every 24 hours proving that this data does still exist. And it was a small bit of data, 216 bytes of data that I stored on the network. But that is actually running locally, right? So we've got that actually running locally. So what I want to do is create this NFT that will actually prove that this data is still there. So I'll actually interrogate the network and prove things are still there. What I'm going to do is I'm going to go through the code, talk a little bit about the code. I'm going to show you an example that I've actually deployed to mainnet in production. And then once I've done that, I'll go back to this local instance and we can have a play around with that if we've got more time. When I switch over between different wallets and different things, MetaMask sometimes gets a little confused. So that's why I'm going to do the production bit first, which is what I've got it set up for. And then we can switch over to LocalNet. Okay. So where should we start here? Okay, let's look at the code here. If I look at the smart contracts and this FVM replication certificate repository, there's a smart contract here and it's set up with Hard Hat to be able to deploy it and use it. But I've also, I actually developed it in Remix originally, actually. I find it a little easier sometimes to iterate on things in Remix. So I had it in Remix. And like I said, I'm going to show it to you shortly in production. But let's go to the code and just see what's going on here. This is a ERC 721 contract here. So we have we're using the Open Zeppelin contracts here. So you can see there's some Open Zeppelin libraries I'm importing, ERC 721, ownable encounters. And then there's some stuff from filecoin.sol. So market API, common types, market types, and some base64 processing stuff. So what have we got here? We've got if you've developed a ERC 721 contract, this will look hopefully familiar. We have a constructor here. We've got a couple of data mappings. One that maps the token ID. So a ERC 721 contract stores multiple token IDs. So it maps the token ID to a piece CID. So that means a single contract can be used for multiple NFTs. And we've got a mapping from piece CID to a list of deals on the network, right? We have a mint function here that takes the piece CID. So this is the CID of the whole piece that is stored in with the storage provider. Now, if you look back at the RAS and if you look back at some of the other talks that were done and the Lighthouse talk as well, you will see mention about aggregation. So a quick recap on aggregation. Like I said, the Filecoin network is designed to store 32 gig or 64 gig sectors, right? Now, that's great if you want to store a large amount of data, but if you just want to store your 50 kilobyte monkey JPEG, then you're not going to want to store everything in there. So you'll use an aggregator. So there's aggregators like Lighthouse. There's one called NFT storage that a lot of people use. This is specifically designed for storing NFTs. And when I store some data on here, it will then negotiate deals with a number of storage providers. So this data that I uploaded back in April, it has gone ahead and stored that with a number of different storage providers on there. I can't remember what that actually is. We'll see. But that is some data there, an image there that was stored in there. And we've got a number of storage providers that is with, right? So aggregators will take data, put it together, and then store it. You can actually see several of these CIDs here, all with the same storage provider. They possibly even have the same deal. Actually, they were probably all part of the same deal that was made. We can actually have a look here and see. No, it's multiple deals here. Yeah, so they aggregate the data together. For this example, we're not going to be using aggregation. We're just going to be looking at the whole piece CID. But if you're doing stuff in the hackathon, you want to have a play around, take this and by all means try and extend it to use RAS or Lighthouse or one of the other storage systems, because that would be a really good direction to extend this and take this, right? So we have our replication certificate. We have to give it a piece CID and we have to give it the deal IDs, right? So if I'm doing this for some NFT storage, if I look at this first CID here, I can click on these links and it'll take me up to the deal on Filefox, right? Filefox is an explorer. And you can see here that we've got the deal ID here and we've got the piece CID. And you can see there's two deals, one that ends in 7.8, one that ends in 3.7. But they're both storing the same piece CID, right? Which is what we'd expect because we want replication, right? This is just two of them. There'll be multiple ones there. So what we want to do when we mint our NFT is we're going to pass that piece CID in and a list of deal IDs. And that is going to put those, it auto increments the token ID and it stores those in those two mappings that we mentioned at the start. There's also a function called add deal ID that can add an additional deal ID into a PCID later, and I'll show you why that is. This was just to demonstrate that you could create a certificate with, say, low replication, just a single copy, and see what it looks like, and then add another one in as well. There's a getter method here that gets all the deal IDs for that token, and there's one here that gets all the providers. Now, what we can see here is in this provider one, we get the deal IDs and we iterate through the deal IDs. And for each one, we call this market API get deal provider. So that will get the name of the ID of the storage provider system that is storing that data. So if we look here for these deal IDs, we can see here these storage providers, and that's what is shown returned there. So we can see those storage providers. Now, here's where it starts to get interesting here. Get active providers. So this is a slightly more involved version of these get providers. It takes a token ID, it returns a list of providers, but we do something a little more complicated here. So what we do is we actually get the deal term. So using the deal ID, we ask the market actor, what is the deal term? The deal term comes back with a start and an end, right? And we can look here and we can get the end. So what we want to do is we want to say, okay, let's make sure that the end has not passed, right? Okay, I can see a little bit of debugging code in here. This true in here means that it's always going to be true here. That was obviously where I was debugging it, so I will remove that. But if we ignore that for a second, then what we have here is the block timestamp. We make sure the timestamp of the current block is less than the end time plus some grace. So in this case, 100 blocks from now. So on a production network, like I say, it's 30 seconds. So that'll be around about 50 minutes. So just short of an hour additional grace time that's just added on there, right? And then we get the, if that's true, then we get the deal provider for that. We add it to our providers. And then this just a little bit at the end here, because of Solidity, you can't dynamically append to a list. You have to create the list to a requisite size. So what we actually do is we now create a second list that we actually resize down. So our list starts off with all of the deal IDs. So say there's 5 deal IDs for this PCID that we've started here. It goes through, it creates a list 5 elements long. It goes through, say only 2 of those are still not past the end time, so only 2 are valid. We add those in, we then resize, create a new list that is just 2 elements long and return that, right? So there we go. I'm just checking if there's any questions. No, it doesn't look it. Right. Okay. So that gets our active deal IDs. What do we want to do with that now? Well, we want to return an image. So this token URI method is what's used as part of the ERC 721 standard to return some JSON metadata. So what we're going to do here is we're going to return some JSON metadata, the name, description, some traits here, so the number of copies and a list of providers. So that's going to turn up in the traits there. But also, here's where it gets fun, we get an image. Now this image, with most NFTs, you're probably used to an image being a link to another, say, IPFS hosted JPEG or PNG or MPEG or whatever it is you're storing. In this case, we're returning a data URI. So we're actually dynamically creating an SVG for our little certificate. And what do we want that to look like? Let's have a look here and see. Got an example, something like this, right? So this is a little SVG I sort of drew up and designed that will show you what it looks like. So this is what we want to create programmatically. And we can see here this generate SVG image. SVG is a vector drawing language, XML based. So all of this here is just drawing lines and whatever here. You can see where we insert some bits. So we insert the PCID, we insert the number of copies, we insert the providers, right? Now here we check and look and see if the number of copies is less than 2, then we're going to add some extra bit on. So we're going to add this danger sign on, right? So a red danger sign on our image. And then we just wrap the end of the SVG up and close the tag there to return that SVG. So there we go. That's our contract, right? So I've deliberately tried to keep it as simple as possible. There's a number of things we could do within the get active providers. So we're checking that it hasn't expired yet, but there is still a possibility that it might have faulted, right? That sector, the provider might have had a hard disk fail and it might no longer be active. It might have been terminated. The sector might have been terminated by the network. So we could also check that as well. For brevity's sake, I've not put those in here, but that's where that would be expanded to do those additional checks there as well. Right. And you can see that if you go back and look at the RAS video and look at the stuff that was shown in that RAS diagram, you could see that the repair and renewal functions use a similar kind of pattern as this, right? They use the market API and they check the health of the data to see whether or not something should be renewed or repaired or replicated there, right? Anyway, that's our certificate. Let's have a go and try it out, right? So like I mentioned, NFT storage, I've got some data I've stored here. I've got some storage providers. When I click on each of these storage providers, I get a deal ID show up here. So I know the deal ID and I know the piece CID. So I'm going to then execute that. So I can do that either via hard hat, and in here you can see I've deployed this to mainnet. Yarn hard hat deploy. I've told it to put it on the main network. I could also tell it to do local net, and we'll see that later. It's deployed, and I've asked it to mint a certificate here. And so again, I've given it the network, I've given it the contract address, I've given it the CID, I've given it who I want the NFT to be owned by, right? Because maybe we want to send it to somebody, and the deal IDs, right? So that's it done on hard hat. And you can see it comes back and gives us the token ID. I'm not quite sure why the N is on the end there. I think it's just when it casts it to a string, it says that. But that's token ID 0, right? You can also do the same thing using Remix. And so this is what I did here with Remix, right? So let's see if I can zoom in on here. Will this zoom in? Yes, good. Okay, so we have the same contract here that I just showed. And we can see here this safe mint function. I've said who I want it to go to. I've given it a piece CID. I think that's the one ends NSEI, which I think is the one from this deal here. Yep, NSEI. So this is the data from NFT storage, right? And oh no, Remix. Here we go. And I've given it a deal ID. So I just gave it one deal ID here, and I called this, and it came back with an ID, right? Now, what I can now do is I can actually go in and add that NFT to my wallet, right? So let's go into Brave. So Brave has a built-in wallet. The reason why I'm using the Brave wallet is because it allows you to set custom blockchains, and it supports ERC 721. So I can actually set it to work with local net. Now, in this case, you can see we're working on mainnet here, but you can see our certificate of replication. If I zoom in here, we can see NSEI, and we can see our providers. Ends 893, which is what we just sent, or 878. Okay, I sent a different provider there. Oh no, that's the provider, not the deal ID. Right. Okay. So that will be the provider from that deal ID that stored that. Right. So we can see it's one provider, and that conditional kicked in and said danger. Right. So we know danger. Right. There's a problem here. So let's add another instance. If I just reload this just to show you, this is live. This is fetching this SVG down live. Replication certificate 3. Now, what I want to do is I want to add an additional provider to this, right? So which provider did I start with here? Let me just see. Providers 893 here, 893. So that was that provider we're using now. So let's try this one here. And so we're going to take this deal ID, and we see it's the same PC ID. We're going to take this deal ID, and we're going to actually execute this in Remix, right? So I'm going to go down to the, where is it? Oh, add deal ID method is up here. So the deal ID I'm going to add is that, and the PCID is the same PCID that I have here. So I'm adding an additional deal ID to my certificate, right? And I'm going to hit transact. That is going to hopefully come up and confirm it in MetaMask. Now, again, this is going to production. This is going to mainnet. So it will take a little while for this to execute. So we'll just have to wait while it goes on and execute. So while it's doing that, we can talk about some of the other bits and pieces here. Or if there's any questions, please feel free to ask them now on here.
Yeah, of course, drop your questions in the channel, but so far all we have had is compliments for the workshop, saying this is amazing and very cool. So yeah, do feel free to ask any questions though as well. We are just happy.
Cool, that's good. That's good. So right, so this is pending on the main network. This is still running here. But like I said, this is, you know, one of the things you could do with this is to use something like this dataset explorer here. So if we if I zoom in here a bit, this dataset explorer, there's a whole series of data sets here. So encyclopedia of DNA elements, fly brain anatomy, folding at home, genome in a bottle. So these are all public data sets stored on the Filecoin network. So some of them are quite large. So this encyclopedia of DNA elements is 2.6 petabytes in size. Stored 40 different storage providers, a number of different locations. You can see country flags there, a number of different locations. If I go into that and look here, you can see it's broken up into a number of sectors that are shown here, 32 gig sectors, and you can see all the deal IDs. So most of these have, what's that, about 7 or so replications on here. You can see the storage providers here. So a lot of these are in China, looks like, but you can see there's some others in some other countries as well in here. Go through, you can see there'll be a number of different countries on here. But yeah, so you can see this is a huge data set on production that's available for people to play around with and test with. Right, let's go back to Remix, see how it's done. Ah, that's good. That's finished, right? So that has added our deal ID. So we're ready for this. Drum roll. Let's go back to our wallet. So we had Danger. We only had one copy. We only had one provider. If I refresh this, demo gremlins be good. Ta-da! The danger sign has gone. So you can see here it says 2 copies now, and it shows the 2 providers there that are storing that data. So you can see 139, the one that ends 893, and the one that ends in 378. 893, 378. You can see them there, right? So we've added both of those to our certificate. And again, we can, we could keep doing this. We could go on, add another deal ID here, and I'll leave that running. And we'll do that as well. Oh, that's the wrong one, safe mint. I didn't mean to do that. It's this one up here. Add deal ID. But like I said, you can mint it and add them all in at the same time. I just added them one at a time just to kind of show the difference between when it's only got one copy and it comes up with that danger sign, right? And again, this is actually minted. This is actually embedded in this NFT image itself. This is a SVG image, and it's actually dynamically generated. So every time your wallet looks up this NFT, it will render that image. That image is actually being rendered. The SVG is being output by the smart contract itself, right? This is not being pre-rendered and saved somewhere. We're not generating a GIF or something, or a PNG or something like that. This is actually directly coming from that code here, this generate SVG image here that's generating this, right? So that whenever you look at it, that's going to give you the current status. So what should happen is in time, when one of those deal IDs disappears, or rather when the deal ID comes to the end when it passes this end time here, and it passes the grace, then it will no longer be counted as active, and so it will drop down. So you could extend this a number of different ways. There's various things I was going to do, but I thought leave that maybe up to you as part of the hackathon. You could look at when it's going to expire. So you could have on this certificate of expiration, you could say, you know, it has 2 copies up until the 2nd of December, right? And after the 2nd of December, it's going to drop down to fewer copies, right? You could say, okay, we're going to have at least 2 copies up until a certain period of time, because maybe after a certain amount of time, maybe there's 6 copies originally, and after a certain amount of time, it might drop down to 5, then down to 4, and then down to 3. But because you can look up all of the deals, you can see when it is due to expire as well. So you could render that on this certificate of replication as well, for example. I did think it'd be nice to have almost like a little graph that kind of says, okay, you know, you've got 6 copies until this point in time, and then it'll be 5 copies, and then 4 copies, or whatever. So, anytime at the end, can you explain the grace parameter? Oh yeah, so the grace parameter, that was just something, just a sort of a nicety we put in here, just to say that once you get to the end, there's a certain period of time before we count it as being invalid, right? So it gets up to, so it's 100 extra blocks. Like I said, each block is 30 seconds on the main network. So 100 blocks, that's 50 minutes, so just short of an hour. So it means that it won't actually register on this certificate as being expired until an hour after it expires. Which, come to think of it, could possibly be the completely wrong logic. Maybe you actually want that to be minus grace, right? Maybe you actually want to say, okay, you know, we should alert when, you know, we're within a day or 2 or a week or a month or whatever it might be of expiration. So you can change that logic to however you want. This is just to demonstrate kind of a pattern here. Email asks, can we handle data retrieval, market storing via smart contracts? Well, any recommended contract libraries? Yeah, go to, that's where RAS comes in. So if we look here, the talk that was done, RAS Deep Dive by Zhangyan, if you go to there, the YouTube link is there. And I think Rory put the link to all the YouTube channel. If you go into the YouTube channel for Encode, you'll see them all there, or there's a QR code there. So that talks about using smart contracts to actually deal with the repair and replication, right? It gets kind of complicated there. So that's why I created this, was just to kind of show like the very minimum of what you can do and kind of demonstrate the kind of the pattern that will be followed, right? That you have deal IDs. Each deal ID represents a storage provider's commitment for a certain amount of time to store the data, and by using a smart contract and you know, encapsulating this as an NFT, then the NFT smart contract itself can actually interrogate those deals on the blockchain, check whether they're still valid, and then render the NFT accordingly. Yeah. Any way to get these deals in a dynamic way, fetch by CID, for example. So there's no way on chain to say, given a piece CID, give me all the deals, right? You have to use an off-chain indexer, and there's some indexers that can do that off-chain. I'm trying to remember the name of one off the top of my head now. There's one called, I think it's SpaceScope, that can do that. SpaceScope. It's called SpaceScope, and that can allow you to do that as well. SpaceScope. Okay, this is a API. I think there's a site that uses that as well. But you can sign into SpaceScope, and you can do it with there, for example. Is blocks timestamps is safe to use in Solidity contract? Yes, I believe it is safe to use. And Slavic saying, playing with some tests in miner API.sol. Before hard hat sends transaction, estimates gas, and the gas failed. Yes, I had exactly the same issue. So I had to set the gas, and you'll see that in my scripts. I think in here you'll see I had to do the same thing. I haven't had a chance to work out why that is, but you will see in my repository here in the tasks when I mint the certificate. Yeah, there we go. I've had to add the gas limit in because I had exactly the same error. I don't know why that is, but I had to put that in. I think it's to do with Solidity API difference or something like that. Jamaro asks, how can we assure that the file we upload will be preserved for X time, or how do we get the X time that the provider will keep it when upload a file in Lighthouse, NFT storage, or other? So when it goes to NFT storage or it goes to Lighthouse, at that point in time, you don't really have the guarantees beyond what those services give you, right? So the services can promise you they'll store the data. It's no real different than Amazon saying they're going to store the data or whatever. It's not until it actually gets on the blockchain and gets stored as a deal that you can start proving it. And that's where this comes in, right? So, you know, I was able to actually take the information from NFT storage, create this specifically that this deal is stored. My mic's just telling me something. Hopefully you can still hear me okay? Let's just
Yeah, we can still hear.
Okay, good. If I look at my wallet, hopefully if I refresh this, we should be up to 3 copies now. 3 copies. There we go. We've got our providers there, right? So this is where you're getting the kind of guarantee once it gets to the Filecoin blockchain, right? But before then, you don't really have that other than you know, the say so of the likes of Lighthouse and NFT storage, for example, right? So you can't really do any kind of programmatic check until you actually have a deal ID and you have a piece CID. Now, when we talked about replication, if you watch the Raz video, they talk about a thing called proof of data sector inclusion, PODSI, right? Now, PODSI allows you to actually check that your CID of your small little piece of data, right, which is, so in this case, this is 103 kilobytes of data, has been included in a 32 gigabyte deal, all right? And PODSI is a way to actually prove that. So Lighthouse will generate that PODSI proof, and you can then submit that to the smart contract. The smart contract can then actually mathematically work through it and be assured that that ID is part of the piece CID, right? So, yeah. Shawshank says, a nice way to dodge that is use the latest Filecoin library here. Yes. Okay. That's good. I am actually using the latest Filecoin library here, but maybe I'm not using quite the latest one. But I am actually, if we look in Remix, you can actually see I'm pulling it in from Filecoin Solidity there. Then I think I'm pulling it in from the right place within my package.json, but maybe that's where I'm going wrong. Maybe I'm not. Should be. Yeah, Filecoin, I am pulling it from the latest version. So there's a version of the Filecoin Solidity library in the Filecoin project repo that is a little bit later than the NPM package, and that's being worked on at the moment, and there'll be a new release to the NPM package soon. Right, so there we go. I think that is everything there. So any more questions? Jamara asks, there's a date below 32 gig that says to 2025. What does that mean? Question? That is the length of the deal ID, right? So this deal ID, its deal ID was from the 1st of August 2023 and runs until the 14th of January 2025, right? So it's about whatever that is, a year and a half. That's the length of that deal. If you actually look at some of the deals from the Dataset Explorer, so I was actually going to demo this, but I actually found that some of these deals have actually expired on here. If we actually take one of these deal IDs and look at it in detail here, look at the deal ID, you will actually see that it has expired here. So this deal ID, you can see here, ran from 2021, from January 2021 to January 2022. So that was for 1 year. So that deal ID is automatically has already expired. demo this in this talk, but I actually found that one of the methods here in where we call, where is it, in the contract, where we call in replication certificate, where we get deal ID, where we get deal term, that will actually throw an error and will actually revert if the deal has actually expired, right? So what was happening was, if you have an expired deal ID, and then because that's not been caught, that was causing the entire contract to revert. Get active providers didn't work, the NFT didn't work, and you couldn't see the image, right? So that was something I found out literally just before this this call when demoing it. So what we need to do is need to wrap that in some error handling code to catch the fact that it automatically detects that the deal has expired already, and handle, exclude it gracefully, right? So we can do that. Shashank says, doesn't know where those errors come from. No, neither am I. I'll have another dig into it. Yeah, looks like there could be some changes needed on the RPC endpoint. So one of the main things that changes was that some of these functions now become view functions. So originally, things like get deal term and get deal ID were not view functions in the version of the Filecoin Sol library that's on NPM. And so you had to actually submit a fee and wait for the transaction to kind of go through. You couldn't have this be a view method because this was not a view method, right? And so in the latest version, that's now a view method, which means this can be a view method, which means token can be a view method as well, right? So we can fetch that directly. If we go into remix, we can go here. If you actually call token URI, you will get data there. I actually copy all of that. You can actually put it into your browser. There we go. And that's the data there. So we've got our JSON data. We've got these trait types here. And then we've got the main image there. And again, you can take that image. I think it will render it. There you go. You can render it directly in your browser, right? So that's the image rendered there as an SVG. That reverse is going to get solved soon. Okay, awesome. Thanks. Get deal activation. Yeah, that'll be cool. So, like I said, this is just a basic bare bones, just to kind of show you the pattern. There's a bunch of other checks we can do with regards to whether the deal is actually active, not just whether it has expired or not, but whether it's actually active. Because when you create a deal, the activation date is often a little way in advance. So you'd submit the deal now. It gives you some time to get the data there and everything to be sorted out, the sector to be sealed, etc. So it doesn't necessarily go live for a number of hours or days normally into the future. And then it will detect whether the get deal activation will detect whether or not a fault has happened and the sector has been terminated due to the provider losing the data, for example. Okay, I've got no idea how I'm doing on time, but I'm at the end. So
amazing. Well, yeah, I mean, Matt, if that's everything from you, I'd love to just say thank you because honestly, yeah, a really interesting session. And I think everybody would agree that it was really simple to follow along. And yeah, everything was really well laid out. So thank you very much for that. To everybody here, I'd recommend you do go back and revisit those FVM recordings, as Matt mentioned. As always, you can find all of the resources in the Hacker Pack and on the Discord channels too. So as a final session from FVM, Matt, I don't know if you have anything you'd like to add before we wrap up.
Just get building. I look forward to seeing what people build. Have a play around. There's a lot of stuff that's fairly new. So things like the RAS stuff is all pretty new. There may be dragons there, but have a go. Have a play around with that, and all of the other. There's a whole number of other partners as well that are that have bounties up. So go through the bounty list, have a look at what you want to build on there, and yes, I look forward to building with you and seeing what you built. I'll be on Discord. I'll be in the FVM channel in Discord, or you can find me on the Filecoin Slack as well. So yeah, ping me on there.
Of course. Well, yeah, one last time, thank you very much to Matt. Thank you to everybody for attending, and we hope to see you again for our final 2 workshops tomorrow. So thank you very much, and hopefully we'll see you all soon. Cheers.
Thanks, Rory, and thanks, Encode. Bye.
Bye-bye. See you.